Oh boy, we got this again. I guess that's how we're gonna start off 2021, I assume. So we got this little number problem that we're gonna have to figure out. Yeah, seriously, what is going on here? Anyway, we got the fourth root of the sixth root of the fifth root of the seventh root of 128 to the power 30, multiplied by the seventh root of the sixth root of the eighth root of the ninth root of 256 to the power 54, and then that's being divided by the seventh root of the eighth root of the fifth root of 1024 to the power 4, multiplied by the 28th root of 512. Yeah, that's again, that is a lot of radical symbols again, but at least the indexes differ compared to, you know, the previous one where it's just all just square roots of 2. Also, well, there was also with a lot of 3s included as well, but at least they decided to change this up a bit. So yeah, hopefully this can come out nice. It's just a number problem, so in any case, solving a number like this, it's gonna be like short and simple. Let's see what we can do from here. Okay, let's see that 128, it can be rewritten, well, both 128, 256, 1024, and 512. Those four numbers can be rewritten in with the base 2, and we're gonna rewrite everything out here as well, especially when we have these all these roots above. They can, with those indexes, we can actually write this in terms of fractions associated with the exponents. So 128 can be rewritten as 2 to the power 7, okay, and then that's to the power 30, and then we can write all these indexes of the roots as in a form of fractions with the exponents. So this is 1 over 7 multiplied by 1 over 5 multiplied by 1 over 6 multiplied by 1 over 4, okay? And now 256 can be rewritten as 2 to the power 8, and then we take that to the power 54, and then do the same thing just like the other. So it's 1 over 9 multiplied by 1 over 8 multiplied by 1 over 6, and then multiplied by 1 over 7. Okay, so that deals with the numerator, so let's focus on the denominator. So 1024, it can be rewritten as 2 to the power 10, and then we can just to the power 4. Okay, and then we write the exponents. So this is 1 over 5 multiplied by 1 over 8 multiplied by 1 over 7, and then 512 can be rewritten as 2 to the power 9, and then we can just take that to the power 1 over 28. Okay, now let's actually combine these together. When we're paying attention to this, I can actually decompose 30, so it can be rewritten as a product of 5 times 6. So that way the numerator with the exponent above is 5 times 6 times 7. So let's see. So we have 2, and then let's see, focus on the denominator. We have that this is, let's see, 7 times 5 times 6 times 4. Okay, and then the numerator, let's see, I have 5 times 6 times 7, because 30 can be rewritten as 5 times 6. Over here, let's see, so it's 2 to the power, let's see, 9 times 8 times 6 times 7. That's just for the denominator. Let's see, we have 8, and then 54. 54 can actually be decomposed to 9 times 6. So I have 9 times, or 8 times 9 times 6. Okay. And then from the denominator, let's see, so 2, then just the denominator, it's 5 times 8 times 7. 5 times 8 times 7, and then the numerator, then we could just leave that as 4 times 10, and then from here this is just 2, and then to the power 9 divided by 28. Okay, now doing this, there's actually some cancellations over here that we can actually cross out. So let's see. So let's see, we have 5, 6, 7, so 5, 6, 7. So that means we're just left with 2 to the power 1 over 4. Over here, 8 times 9 times 6, 9 times 8 times 6, they cancel. So we're left with 2 to the power 1 over 7. And then divide by this. Okay, and then from here, we have that this is 2 to the power, let's see, 4 times 10 is 40, 5 times 8 is 40, and then times 7. So let's see, that's 4. So let's see, you have 40 here and then a 40 times 7. So the 40s cancel out from top and bottom, and then we'll get that this is 1 over 7. In other words, if you just multiply this out, you get 40 and then divided by 40 divided by 280, and then that simplifies it out to 2 to the power 1 over 7. And then over here we have that this is 9 to the 9 divided by 28. So, and now we see that the 1 over 7s from with the base 2, they cancel. So we're just left with 2 to the power 1 over 4, and then divided by 2 to the power 9 divided by 28. Okay, so we can just use our rules of exponents and then write this under just under one base instead of separating. So this is just 1 over 4 minus 9 over 28. But I can simplify this out a bit. So we get that this is, let's see, let's simplify this out. We get that this is 2. Okay, well, they actually can be written as 28 minus 28. So this is 9. And then up here, this is 7. So therefore, I get that this is 2 to the negative 2 divided by 28. But that also can be rewritten as 2 to the negative 1 over 14. And therefore, we come to the conclusion that this is equal to just 1 divided by the 14th root of 2, like so. Okay, and there you have it. That's not as complicated as I thought it would be. All right, that's it's pretty cool if you ask me.